Hi everyone, Alex is here. WebAssembly. Why do you need it? How to use it? Let's finally discover that. WebAssembly language. So, like all of us knows that all the web pages, they're working with HTML, CSS and JavaScript. But here I'm telling you about which WebAssembly and what's that, why do you need that, how does it work. So basically, we have a lot of modern web applications right now. Probably you heard about progressive web applications. Probably you have seen that there are also video editors online and really powerful, not like something where you can just stream your video. No, like powerful video redactors. Also, like you have editors in your YouTube studio. And here we have a question. How we can do that? If you think that you can use just simple JavaScript or any frameworks that are using JavaScript to create such thing, you're deeply mistaken. Why? Because JavaScript is quite fast programming language, but it's totally not the fastest. And if you will compare, for example, computer's video editor that's created based on their processor, their memories, their their unique programming languages, you will see one difference that is much more optimized. It has much more performance than the one on the web page. So how we can use these video editors there? Why it is really okay and normal to have incredibly powerful applications, even video games, even virtual environments inside of your web application. Everything's quite simple. They're using WebAssembly. It's not always WebAssembly, but I think in such cases it will be 90% of that. Why? And what does it do? So, WebAssembly that helps you to take the specific function written code and put it inside of your browser with machine native code, and it will be much faster than JavaScript. So WebAssembly helps you to work with your performance. It's really rare, so most of web applications don't need that. But if you really have video editors, any graphic hard things where you should change, it should make a huge, for example, nested, like a lot of really hard work, WebAssembly, it is the thing that you must use. So once more, games, video editors, big graphic editors, like really huge one with a lot of diagrams. For example, even Figma I think can go in this way. Something that when you will be using JavaScript, you will tell me why it's so slow. So when you have this question, you have optimized your application, like JavaScript was optimized, and you still have this question, this is where you should use that. When you have tried, for example, web workers, any other stuff, writing something on Vanilla JavaScript, if you have used all of that and it's still really slow, not so fast as you think, WebAssembly is the way you should go. So, an idea of that, when you have JavaScript, it basically takes your file to instantly to browser's engine, and it converts that to the programming language that this browser understands, and then to machine code, and everything's understandable. What does WebAssembly do when you're using JavaScript? It's fetching this file, so JavaScript can fetch all the files. The problem is how browser can respond to that. We're taking WebAssembly file. Then we are going to our browser's engines. And there is also WebAssembly engine. So when you take specific file with specific extension, your browser understands that it can't be done with JavaScript engine. You should go to another programming language. Yeah, there are also others. Yeah, JavaScript is not the only one right now. But in any case, it's the only one that can be run from index.html file. And index.html file can take others to be run. So in any case, JavaScript will be always the one that will run your application. So when we have WebAssembly, this file is nearly painted to native base code. So your engine should not convert it, but it's like your browser won't convert it one more time. Yeah, it maybe convert like from some specific things to computer native language to bytes code, but it will be much faster than JavaScript. So an idea here, it is WebAssembly is taking some optimizations that it compiles from C, C++, Rust, and it goes to nearly native machine code that you won't understand, but the computer will understand. And when you are taking this code, going to browser, it's nearly at 1 second, it understands what to do. It doesn't need to be taken from that programming language to native code language. So it will be much faster than JavaScript will go to native code language. That is the idea. So WebAssembly is going from its code language to browser's understandable code much faster than JavaScript. And this is one of the biggest things here. And also, WebAssembly is using much more powerful programming languages behind of that. While JavaScript uses its own engine, WebAssembly is just converting it from others programming languages that are faster than JavaScript. So these two things making WebAssembly faster than JavaScript. This is the thing. That's how it works. And based on that, let's discover how it will have a look in our code. And I think that if you have any questions, this code will fix most of your questions. Let's go. So, as usual, our CLI file and our Fibonacci demo. Why Fibonacci? It is the easiest way to show you the difference of these two applications. So, firstly, we should install Rust, because based on Rust we will be using our WebAssembly. WebAssembly is also just a lot of the time it is abbreviated as Wasm, so WebAssembly, just for you to know. And you're just taking that, putting that here, it will automatically start this code. I won't take it because we already have that. And then you just click in enter, and you will just confirm that install. You know what? In any case, let's do that one more time. Like, you'll just see how it will work. So it will ask you this question. You can just hit enter. It will use the first one. Then you see the message that this terminal should be reinstalled. For that, you cannot like close that and open that. You can just click on the plus button here. It will open the new terminal and it will work. Sometimes you should use source cargo fish or this one if when you hit here, the next terminal, you want to install WebAssembly pack. So you see this request, you just copy that, pasting it here. And if you have errors here, cargo is not defined, so you should use one of these codes to tell your terminal that, come on, use please Rust environment to persist this install request. So we're hitting enter. It already tells that we have that, so it will ignore, like overriding that. So we have everything. After that, you're creating a file, Fibonacci demo. And what do we have? We have a couple of files here. I'll tell about them a little bit later. Right now, we're going to create Rust. So in a Fibonacci demo, you're using cargo new, where you're taking library Rust Fib. So this will create the folder that we'll call Fibonacci. It will use a simple structure, as I remember, without log file. Yeah, without log file, but in any case, let it be right now with us. And the only one thing that you should do, you have Rust programming language. You should just go to library and right here what you wanted to create, like which methods you wanted to work with on. So that's after you created this file, you have this folder that have 1, 2, 3 files with one folder inside. As you remember, log file will be created afterwards, but in any case, if it is created, you don't make any attention of that because it's just what it is using, like which libraries and etc. So we are taken to this library. You shouldn't rename that in your folders, nothing like that. You should just understand, you're using WebAssembly preloaded. Then this hashtag tells that this function will be overridden to WebAssembly. It will override it to machine-like code. You're telling what you're taking that's what it should be. So in general, one of the interesting things here that you can use other programming languages, for example, like C, like C++, or for example, once more time, Rust, okay? And you can convert your already created code on backend to use that on web. So sometimes we should use backend logic on a web for some specific reason, so this thing can help you. Of course, it's not better to do that, but here you can do that and it will be really working well, it will be working fast. So this is the WebAssembly, so you can convert this to machine-like code and it will be used in every part of your application. And also WebAssembly is starting to be used on mobile application. It will create a new era, so you can just combine this logic on native based code editor. So it's not Kotlin, it's not Reactive native that is compiling a lot of times and it's not so powerful, but this thing is the most powerful. It will be compiled to really native like native based code. So that's why it's powerful. It will be taking, in our case, WebAssembly, and also we have JavaScript one. So just to see the difference, you will see. Let's go further. What you'll do after you have these functions? We should go to our compiler, open a new, or just in my case, coding folder terminal. We're going to Fibonacci to Rust Fib, so in this folder. And we should run wasm-pack build target to web, because here we can use different targets. We'll be using only web today. So we're running that. And you see that something is being compiling, building. Voila, we have target, we have package file, and that's what we're using. And let's look at this file. We cannot open that because it is use unsupported, this one, but let's try. So this is machine-like code that will be much faster to be understood by your computer than simple JavaScript one. So we will be using simple JavaScript code and we'll compile it to this one. This one will be much faster. This is the thing. And here we have a couple of other files, so just our TypeScript with some of the typizations. Here you can use that. All of these things will be just run on your mostly local machine to be easier and better to understand what depends on what. And it is creating a Rust Fib file. So this one, as you can see, what we're using here. So you can see that we are importing our Fibonacci JavaScript. So you can use, we're here have here also our Wasm file. So it will it understands what we should to import. It arises here, and this file should be done only for one thing. So it will be just compiles for our JavaScript to understand what we should import, from where we should import, and how we should initialize that. Nothing more. So it will just import that. That's nearly all, and it is created by E7, so you shouldn't do anything with that. And our script is created, so that's all. Like, you have written it on this place. You're just converting that, and it will create such files. So that's all what you need. And finally, after we have done this, we have our HTML file. So our HTML file that will let's take a look on that. So we have here a couple of styles, Fibonacci demo. We'll have like that we should enter some of something. So we're calculating something. We have two things, just for you to compare the results for JavaScript and WebAssembly, like how it will be really faster. So JavaScript, our result, our execution time, our WebAssembly with execution time. And we're taking with model, because we'll be inside of that file we'll be importing our WebAssembly. That's why we should write it as model. So we're importing our index JavaScript file. What this file will have? It will have just, so first we're just importing our Rust fib file. So we have initializing, and we have Fibonacci Wasm method. So basically, as I remember, you can use only that one, and you can delete this one. I think it will. One sec. Not. I think. No, it's dependent. It's dependent. Sorry, I forgot. Probably. I gotcha. Probably we'll be able to delete this one. It will be taking this one, and we convert it from here to Wasm file, and it will be able to take here. In any case, you'll be able to take a look on that, because I really forgot how it should be better. And we'll take in this Rust Fibonacci file. We're taking package, and we're taking our JavaScript file. If we have initialized, and we have Fibonacci Wasm, like the function that will run. And we have created like the same function just on our JavaScript, just to test it out, like the native variant and with Wasm. So here we have initializing of that. We're initting our Wasm file. You see, like we're taking Rust fib JavaScript just to have the method initialize. So JavaScript method will have initialize there, and we have our function that will be running. So, but before of that, before we'll run this method, we should take our Wasm file, so our application will understand that. So we have this function, so it is taking that, it was successfully run, and the window calculate Fibonacci. It will run this method here, and unload of our application. So before, like, no, I'll tell in another way. So first, unloading our application, and when we are loading that, when even DOM is not loaded, but we just entered the web page. The first thing first, we're importing this file. And after we imported that, we can run our calculation Fibonacci. Before that, it won't be run. So we are running that. If we have any problems, like we'll tell, like we're missing something. And here is not like there is not something hard here. So we're just taking Fibonacci input, like what we have written on our input here. Then we're just seeing if the number is okay for us, and we're taking JavaScript result span, time, and WebAssembly. Like it will just taking that to our variable, so it will be easier to use it later. So for JavaScript starting file, we're creating a const file that we're starting our application. Then we're using our Fibonacci file method, this one, and then we have end time. That's all. Like, we have two timestamps. One way we have started, then run our function result, then when it was ended. This function performance now works really fast, so you should worry about it will be accurate. So, and then we'll just take in JavaScript result span, so what we have from our Fibonacci JS native, so from this method. So which result do we have? And then we have JavaScript time, so it will just will take our end time minus our start time and fix that to 2. That's also we'll be able to know the exact time in milliseconds in our UTS time, so remember. Yeah, so that will be quite fast. And the same with Fibonacci, so if it is founded, so is function, because if it's not, so like if Fibonacci wasn't found, it will have a problem, and we'll also write in here that it wasn't installed. So if it was found, we're also running start, performance end, and the same way we're running our Fibonacci Wasm method as here, like the same way, you see, nothing else. And also we're taking this method the same as we have been calculating it here. And right now it's interesting for us to discover how does it work. For that, let's go for our fifth file CLI to run the server. We can put it not here because it's Fibonacci file, so we're making a new terminal. So this is the fastest and the easiest way to run your terminal. So without needing anything, you're just npm install global serve and you just run the serve. That's all. And we have our local host. Let's take it on. Let's go here. So we see what we have right now, and it has already run our 35 for our Fibonacci demo. And you can see at once, like, what is our result, what was the time for JavaScript, and Wasm to calculate it. The difference is approximately in 5 times. It's 5 times faster. Like, this thing is in 5 times faster than for your code to understand this one. That's why this one will always lose for something like this one that will be already converted to machine-like code. That's the thing. And if we will write 40, just see the difference. 75, nearly 1 second, 176, 29. That's the difference. And you can also see here how it is imported. So we're importing our JavaScript file. This one will import Rust file. You see they also have its own icon, so it understands what it is. We have response from here. Everything is initialized that the specific WebAssembly driver will be taken to persist this file, so it won't be run as JavaScript. So browser understand that. It just have if else, something like that. And if it is Wasm file, it will be taking a Wasm WebAssembly engine to understand it. And and then it will run to programming, like to computer-based code, and then it will be able to run on our machine, and browser will understand it because browser just shows what our computer understands. That's all. And that's the difference. So, but here we have a problem. As you can see, when we're clicking 40, or you will write much more, like this button was glitching. So you can see here, for example, 40, I can write 40 the second time. You can see I have my cursor is here, but it's still like a little bit black. Why so? Because it has only one thread, main thread, and it's blocking that. So JavaScript cannot be updated. If we'll be using WebAssembly, it will be the same issue. So it will be just taking your main thread and will block it. So if you have something big to calculate, it will be really hard to do. You'll be always should do using your web worker. And here is an interesting thing. how we can use our web worker. So this is our terminal, what we see here. We can just import our index.js. As remember, it won't be taken here, so we should restart our server. I hope that this one will work better. Probably. 1 sec. Yeah, and you'll see how. So, what will have the difference here? What is web worker? Web worker, this is a specific thing in JavaScript that helps you to make a new thread for making some functions. So it won't block your main thing, like main logic. And that is important with UI. For example, when you're clicking something and your whole application is glitched, this is the problem. This is when web worker should be used. It will help you to divide your threads, like your functions, and it will run faster and more smooth, and your UI won't glitch. This is an idea. And here we have also, like, we're taking even the simple native code, like that is not in web worker, and we'll taking that with web worker. That is for our, let's click this one. That is for our web application. So we have this file. What we have here, like native JavaScript code, you know that. We're taking the file that calls Wasm Worker. We're taking it as a new worker, and we're making a message that we're taking our data. We're looking for the answer of our web worker. If we have error, we'll write down that we'll have error. If our worker will have error, web worker will have error, so like inside of that file. And how our calculations are doing. So we're the same taking our number, the same checking that. We're taking JavaScript, we're running JavaScript the same way. Here we're changing how to work with Wasm worker because we won't wait until it will do something. So we'll just making a pause to that. It will take as much time as it need. And first we will write in calculating and NA to our time. And when you're going here, you can see here that it is glitching some little bit. Do you see? And that's okay, that's good because it is thinking. Right now we have error because I think I was doing that too fast, probably. Yeah. So if we'll do that too fast, at one moment we have error. But in any case, just loading our WebAssembly file, and let's discover how do we have that in this very file. So each just we're making post of information that do we have. So we're passing our n, so our number, our event have type, payload, and time that we'll be using. Yeah. So all that we have here, and let's discover that. So here we're taking our JavaScript like it was here. So we're just moving logic a little bit. Then we're initializing our WebAssembly in a little bit different way, but you'll see the same thing. So is this file initialized? When it was, we were writing true. If we have fail, we're writing that we have fail, and we're posting that it was a fail, was some error, which type, and what was the problem. Then this thing will help us to understand if it was ready yet or not, because you can run, for example, the method or make a post faster than it will be initialized. So we should have a time for initializing that, a couple of milliseconds, but if we will make that run faster, we'll have a problem. So if, for example, this thing will be run initially on load, we'll have a problem. We'll have a problem because probably Wasm file won't be ready on that moment. So, but basically when you're writing that on the another method and users should click something so that function will run, basically it will always be loaded in that time because I don't think that user will be manually clicking on something during some milliseconds. Even some automated things also have such problems, so it also takes some couple of milliseconds to them to click somewhere, and I think during that time your file will be installed. So just we're checking if this is installed, we're checking our number, we're checking if the number was good, if it is none, we're just saying that invalid number was received, and then we're taking our performance here, we're sending back our result, our type, our time that we have, like our object that we have created, and we're running our Fibonacci Wasm. And here is the thing, very interesting. Yeah, so we're just passing that back. So you see here that we're checking time event from payload, from what do we have from our message. So this thing will be looking for answer from this hello file. And this function event data will be taken when we are running this method. That's how it works. And let's go back to our file. Let's see the difference. And you'll see how much time the worker also takes to be run. So it is like just native JavaScript code, but how just JavaScript code is longer than even some calculations with WebAssembly. So when we're running that, you see that 40 is taking 50 milliseconds more. This one is huge as it always is, but right now we'll begin one more time. 81, so it's in 50 milliseconds more, but in any case, with even these 50 milliseconds, we're unblocking our UI. We can just come here, we can just not using this method at all, and you'll see that our UI won't block in any case. We'll write here 50, 40 is recommended. Our UI won't be glitched, and you see it is calculating, and it will return us the answer when it will be able to. So it can take a long time, especially 50 is incredibly long, but our UI is working good. We can see how is our memory is 78 megabytes. Incredible. And it has taken 21 seconds to write the answer back to us. Can you imagine how long it will take for our JavaScript? In 5 times more. So it will be approximately 2 minutes. Here, 21 seconds. That's when you're using that. That's the case. You're welcome. Thanks everyone for watching this video. Hope that it was interesting to you, and also write down in the comments what you're expecting to see more. Maybe some more programming languages, maybe some more functions, maybe some practice how to write some code. In any case, I was really happy to see you here and wishing you all the best. See you the next time. Bye.